Welcome, UPSC aspirants, to this special explainer from Rungta IAS Academy. Today, we're diving into a highly probable topic for your General Studies Paper 3 syllabus. This is one of those perfect intersections where science and technology meets internal security. And I'm joined by my colleague today to really unpack this for you all.
Thank you. Yes, aspirants, you'll want to pay close attention to this one. The whole nature of conflict is evolving so rapidly right now, and understanding these modern nuances of space warfare, well, it's absolutely critical for your mains preparation this year.
All right, let's start by challenging some of our basic assumptions. When we usually imagine space warfare, we picture physical destruction, right? Shattered satellites, huge clouds of orbital debris. But the reality today is much quieter and arguably far more dangerous. Modern orbital conflict is silent. You actually don't need to physically blow up a satellite to completely paralyze an adversary anymore. Instead, the whole game relies on digital disruption. And that brings us to a really crucial conceptual difference. Could you perhaps contrast that traditional warfare with this new modern approach for the students? This really sets up a perfect framework for a comparative mains answer.
Absolutely. So think of traditional kinetic war. As the military theorist Karl von Clausewitz observed, it seeks a definitive decision through pure physical destruction. You see the smoke, you see the visible debris. But modern cyberspace warfare operates entirely differently. It's characterized by sudden signal loss, deliberate misdirection, and massive system failures. These are highly ambiguous, deeply deniable attacks. They're designed to project state power without actually trying to secure clear territorial gains. It's essentially a state of constant, low-level friction.
So how does this invisible interference actually happen in practice? It primarily comes down to three main tools. First, you have jamming, which simply blocks the signals. Then there's spoofing, which is sending false data, like feeding a system altered GPS coordinates. And finally, ground station hacking, where attackers physically seize digital control of the ground systems. And the real-world threat here is immense. Just look back at the initial hours of Russia's invasion of Ukraine. A massive cyber attack crippled Viasat's network. Now, that wasn't just a space issue. It triggered these cascading earthly failures, literally severing critical civilian communications right across Europe. Exactly. So aspirants, please write this phrase down for your essays. Loss of functionality is the new shattered glass. If a cyber operation disables a satellite that's supporting our power grids, the real-world consequences are functionally identical to a physical missile strike. But this exposes a massive legal blind spot. The UN Charter Article 2.4 explicitly prohibits the use of force. So the big question is, how does international law even begin to handle these invisible cyber strikes when there's absolutely no physical smoke or fire? Right, and this is exactly where international law falls incredibly short, which leads us to a core concept you absolutely must note down: the attribution gap. Under the International Law Commission framework, proving state responsibility requires a very high level of evidentiary certainty. You literally have to prove beyond a doubt exactly who attacked you. But in the digital domain, aggressors are constantly using proxy networks and spoofed identities to maintain strategic anonymity. So as long as our legal frameworks require visible, physical proof, this reactive posture gives a massive structural strategic advantage to the attacker. Let's actually build on that with another critical vulnerability. The Outer Space Treaty and international humanitarian law, they both rely heavily on the principle of distinction, meaning warring parties must clearly differentiate between civilian objects and military targets. But what we're witnessing today is the total collapse of the civilian-military divide. Modern satellites are just dual use by default now. Your standard civilian GPS networks and commercial broadband, they are routinely supporting military intelligence gathering and live drone targeting. Precisely. And if you face a question on space militarization in the exam, here is your model answer definition: the Starlink precedent. This phenomenon occurs when massive commercial constellations essentially provide space as a service for military kill chains. Because militaries are now actively piggybacking on commercial infrastructure, the whole idea of a purely civilian satellite has just become a legal fiction. In this new environment, an entire commercial network abruptly becomes a legitimate gray zone target, even if that exact same satellite is simultaneously providing internet to schools or hospitals. So, given these immense evolving threats, what is India's way forward here? How are we actually going about securing our own critical infrastructure?
Well, the good news is India is taking some vital steps to move away from just having advisory norms toward actual enforceable standards. The upcoming 2026 CERT-In and CIA India guidelines are absolutely central to this shift. First, they aim to institutionalize a strictly secure by design doctrine. Second, they mandate embedding robust cybersecurity protocols into every single stage of a satellite's life cycle, from manufacturing to deployment. And third, they specifically require layered technological safeguards to defend against those exact threats we just discussed: signal jamming, spoofing, and unauthorized access.
However, as serious UPSC aspirants, you must always provide a critical evaluation in your answers. While we certainly have solid policy progress with these new safeguards, we are still staring down a major vulnerability, which is the enforcement gap. India is currently expanding its physical presence in orbit far, far faster than it's building the actual capability to detect and trace these silent cyber attacks in real time. Without cooperative international attribution mechanisms, this digital ambiguity will simply continue to heavily favor the attacker.
That is a brilliant, highly balanced analysis. Aspirants, as we wrap up today's session, we want to leave you with a direct mock interview question to really test your strategic thinking on this. Remember, the objective of modern war is no longer just to destroy a satellite, but to entirely disrupt the society that depends on it. So ask yourselves, how should the global south address the very unique threat of orbital dependency, where hosting our crucial digital backbones on foreign commercial constellations could literally allow a silent cyberstrike to paralyze a sovereign state's ability to govern? I want you to ponder this carefully, draft your own strategic solutions, and keep preparing hard. Thank you so much for joining us today at Rungta IAS Academy.